Okay, let's look at section 2.2 subsets. Set A is a subset of set B if every element in set A is also an element of set B. And the notation for that looks like an elongated C with a line under it. So that's read A is a subset of B. Notice that every set is a subset of itself because it's obvious that every element of A is a member of A. Set A is a proper subset of set B if set A is a subset of B, but sets A and B are not equal. And so the notation for a proper subset is the elongated C, but it doesn't have the bar underneath. Okay, try not to confuse the symbols for the subset and the proper subset. In some subset examples, both symbols can be placed between the sets. But by contrast, there are subset examples where only the subset symbol can be placed between the sets. Because the lower part of the subset symbol suggests an equal sign, it is possible that the sets A and B are equal, although they do not have to be. By contrast, the missing lower line for the proper subset indicates that sets A and B cannot be equal. And of course, if I were to draw a bar through it, now this says A is not a subset of B, or A is not a proper subset of B. Notice that the empty set is a subset of every set, and furthermore, a proper subset of every set except for itself, because think about this, the empty set is the set with no elements, and so there can be no elements in this set that are not in your other set. The empty set is a proper subset of every set except itself and a subset of every set. Okay, let's observe some cases of subsets and see if we can determine how many distinct subsets can be formed from a set. Okay, so here's the empty set with no elements. Let's list all the subsets. Obviously, it's only the empty set, so the number of subsets is 1. If I have a set with one element, the empty set is a subset, and of course the set with that one element in it, so I have 2 subsets. If I have a set with 2 elements, I have the empty set and the set itself, of course, and then I can, in this case, have a set with just the element A, with just the element B, giving me 1, 2, 3, 4 subsets. If my set has 3 elements, right, cardinality of 3, then I have the empty set and the set itself. Those are subsets of every set, the empty set and the set itself. And then I have sets with simply the element A, the element B, the element C. I have a subset with AB, AC, and BC. That gives me 8 sets. So this suggests that when we increase the number of elements in the set by 1, the number of subsets doubles. The number of subsets is a power of 2. To find the number of subsets, we can say 2 to the n, where n is the number of elements in the set. Notice 2 to the 0, anything to the 0 power is 1. 2 to the 1, 2 squared, 2 cubed. All right, so let's try to answer some questions that you might see on your homework. Okay, let A be the set with the elements 1, 3, 5. B is the set of elements 1, 2, 3, 4, 5. C is the set of all x, such that x is a letter in the word proof. So P, R, O, F, right, 4 elements. D is the set of all y, such that y is a letter in the word roof. So R, O, F are my elements, 3 elements. E is the set of elements 5, 4, 3, 2, 1. Determine whether the subset, the proper subset, Both or neither can be placed in each blank to form a true statement. So A and B. Okay, first of all, let's determine if it's a subset. Okay, that means every element of A has to be in B, or there can be no elements in A that are not in B. Well, 1 is in B, 3 is in B. Yes, this is definitely a subset. Now the issue is, can a proper subset be placed there? In other words, are they not equal? Yes. So between here, I can put both symbols. What about between C and D? All right, C is a set of all X such that X is a letter in the word proof. In other words, we already said that this is P, R, O, and F, and D is listed in roster form. I cannot do my braces on this tablet. Is R, O, F. So remember what it means to be a subset. Every letter in this set must be a member of this set, or alternatively, another way to think about it is there cannot be any letters in this set that are not here. Oh, P. This is neither. It's not if it's not a subset, it's definitely not a proper subset. So I can't place either of those symbols between those two sets. What about E and B? Okay, I already have that in roster form and this in roster form. All right, E. Are there any elements in E that are not in B? Nope. So it's definitely a subset. Now, is it a proper subset? Oh, no, they're equal. So the only thing I can place between these two sets is the subset symbol. It is not a proper subset. D and C. Okay, here's D and here's C. Now this time, I want to know if there are any elements in C that are not in D, right? I'm sorry, other way around. In D that are not in C, because this has D listed first, right? So every element of D must also be in this element, and it is, so I can use the subset symbol. The question just becomes, can I also use the proper subset? And if they're not equal, which they're not, then I can use both. What about A and E? Okay, here's A, 1, 3, 5. Here's E. Okay, A does not have any elements that's not in E, and they are not equal. I can use both. A is indeed a subset of E, and not only that, it's a proper subset. Okay, determine whether each statement below is true or false. If false, explain why. Now again, be careful with your symbols and your notation and specifically what it means. Look at the difference between these two. The only difference is this is a subset notation, this is an element notation. Canada cannot be a subset of anything. It doesn't matter if it's listed over here because this is not in set braces. It's not a set at all. It cannot be a subset. This is false. Okay. However, it is an element. This is the set with elements. Mexico, United States, Canada. Yes, Canada is one of the elements here. Now, if we were to list Canada as a set, right, the set with an element Canada, now I can call that a subset. But it is not an element. No, it is not an element, but it is a subset. In order for this statement to be true, it would have to look like this. I'm going to use an abbreviation here. Canada, right, is an element of the set. Now, if my elements indeed were sets themselves, now this would be true. Notice the difference and pay very close attention to the subtle distinctions. This now is true because, yes, here's an element in this set that looks just like this. All right, what about this? 0 is an element of the empty set. Okay, well, there are no elements in the empty set, so this must be false. Okay, 0 is a subset of the empty set. Well, again, this is not written with set notation. It can't be a subset of anything. Even if it had braces around it, it's not a subset of the empty set. Okay, and the empty set is a subset of every set, a proper subset of every set but itself. So that is true, right? There are no elements in the empty set that are not in this set. Since there are no elements, that makes that true. Alrighty, let's look at some more. What about this one where it asks us to write either is not a subset or is a subset and each blank to make a true statement? Okay, the set of all x such that x is an element of the natural numbers and between 5 and 12. So again, if I'm going to list that in my roster form, I've got, no, don't include 5 or 12, so 6, 7, 8, 9, 10, 11. And this one is the set of all x such that x is a natural number. And between 2 and 11, including 2 and 11, well, I know my answer right away. If there's a 2 over here, right, 2, 3, 4, never mind, 5, I was 6, 7, 8, 9, 10, 11. So be careful, I was just about to make a crazy mistake. Okay, so every element over here is definitely listed over here. So this is a subset of this set. What about this? The set of all x such that x is a person. Is that a subset of the set of all x such that x is a woman? Remember, there can be no elements over here that are not over here. And men are over here. So this is not a subset. If it was written the other way around, it would be a subset. Be careful about that. As just indicated up here, very easy to get that confused. Okay, here's the empty set. Here's the empty set. Now, if it were using the proper subset, I'd have to say no. The empty set is not a proper subset, but since they are equal, I can use the subset symbol. List all the subsets, first of all, for Romeo and Juliet. Well, one thing I know is that there will be 4 subsets because 2 to the 2, there are 2 elements. So just to help me make sure that I get them all, and I also know that the empty set and the set itself, right, so I'm just going to say R and J for easiness sake, are subsets. Right? Now I need 2 more. So R and J, and because I found 4 of the sets, I feel pretty confident that I've listed all of the subsets for the set Romeo and Juliet. On this one, because there are 3 elements in the set, I know that I'm looking for 8 subsets. And again, I know that the empty set and the set itself are 2 of those 8 subsets. So now I can list each one individually. So 1, 2, 3. And find some kind of way, to make it orderly so you can keep track. Maybe I'm going to list 1 and 2. Okay, 1 and 3. Now I've paired 1 with the other elements. Let's move to 2. So 2 and 3. And because I know there must be 8, I can check and determine if I found them all or not. 1, 2, 3, 4, 5, 6, 7, 8. So here is a list of all of the subsets, and I feel confident that I've gotten them all. Okay, calculate the number of distinct subsets and the number of distinct, I think that's supposed to say proper subsets. So distinct subsets and distinct proper subsets for each set below. excuse me, 1, 2, 3, 4, 5 elements. So 2 to the 5th is 32. Right? So there are 32 subsets. And look at the way the subsets work. The empty set and the set itself is always a subset, and this is not a proper subset, but every other one is a proper subset. So we can always find the number of proper subsets by subtracting 1. So 31 are proper. The set of all x such that x is a day of the week. Okay, well, since there are 7 days of the week, I know there are 2 to the 7th subsets. So 2 to the 7th is 128, I believe, meaning 128 minus 1, 127 of them must be proper subsets. Okay, if I were to list this set in roster form, I would not include the 2, but I would include the 6, telling me there are 4 elements in the set. So 2 to the 4th is 16, meaning 16 subsets, and 16 minus 1, 15 proper subsets. Okay, so that should take care of chapter 2.2 on subsets. Go in now, see if you can do your homework. Let me know if you have any questions.